Hi everyone. Hey, it's Mr. Morrissey here at Bedford High School, and today we are looking at hyperbolas. So I guess the first two pages that you have in front of you have a lot of information about hyperbolas, and I think the examples we're going to do are going to be um, pretty good explanations of how to graph hyperbolas. But at least in terms of a basic definition and an initial formula, if you would just read with me, it says a hyperbola is the locus of all points P in a plane such that PF1, so if you look, this P right here, this P to focus 1 minus um, this P here I can highlight. I've got to get used to this highlighting. So from this P down to the second focus, so that's focus 2, okay? Um, Now on your copy it's going to say the absolute value of the difference. So the absolute value between the difference between those two lengths is going to be a constant. And let's see, a hyperbola is made up of two branches, and an equation is right here, and it's missing. The Microsoft Word has some issues when it copies over equations sometimes, but the formula for a horizontal hyperbola is this. So it's x squared over a squared minus y squared over b squared equals 1. And it's always going to equal 1. So always 1. Okay? And in this case, a squared is not necessarily bigger than b squared. So in the ellipse, remember, a was always bigger than b. Here, this is probably the one key thing to know. If you have a horizontal ellipse, horizontal, then it's x squared over a squared minus y squared over b squared. If you have a vertical ellipse, this is explained in detail on the next page, but a vertical ellipse is going to be the reverse. It's going to be the y squared over a squared minus x squared over b squared. So you notice that the a term is always under the first term. So in a, let me highlight it, in a horizontal ellipse, the a is underneath the x squared term, and in a vertical ellipse, the a is underneath the y squared term. Um, you're going to see when we graph this, there's this idea of asymptotes of the what do you call it, the hyperbola, which we'll get into how to graph that. And there's also the idea of the focus. Now in this case, the focus, like if you look over here, whoops, if you look at this hyperbola that I've just put a star next to, um, this is going to be an example of a horizontal hyperbola that's facing out left to right. The focus is actually going to be a point on sort of the outside of the hyperbola. So the C point, this would say, call this negative C, and that's C. And this here, this would be A. This point here would be A. And you can see there's only going to be two intercepts. If there's a horizontal hyperbola, then the intercepts are on the x-axis. If it's a vertical hyperbola, then the intercepts are on the y-axis. But we're going to practice this all in 1 second, okay? Um, I think probably the most important piece of information is on page 2. And remember, you can stop the video at any time, but if you look at the bottom of page 2, this is how I would suggest to graph a hyperbola. Determine if the hyperbola is horizontal or vertical. I sort of already explained that briefly. And then determine the a and the b values. Find the vertices, because that's probably something that's good to know how to do. Draw in this rectangle, which you'll see what I'm talking about when I say that in a second. Then draw in the asymptotes. That's really easy. That's just putting in like that dot, 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 asymptotes. Um, and then sketch the graph. And then if asked, find the foci. So there's 7 discrete things that you want to do to produce a hyperbola which looks something like here, or, let's be all nifty here, or here. Okay? So we're going to practice that. We have 5 examples today. Um, this is not an easy topic, so just keep that in mind, okay? But we're going to start with number 1. So let's get one problem under our belts here. And it says graph and identify vertices, asymptotes, and foci of 25 y squared minus 4x squared equals 100. Um, the first thing I'm going to notice is this is not 1. So I'm going to make it into a 1. Really working on my penmanship this year. It's been a big goal of mine. Okay, there's the standard form equation um, of this hyperbola. And the next thing I'm going to notice is that this is a vertical hyperbola. Oof, vertical. My spelling was never the best in school. So vertical, and I know it's vertical because the y term is first. It's not the best math explanation, but the y term is first. So this is going to be a vertical hyperbola that's shooting up and shooting down. And I can see immediately a is plus or minus 2. So real quick, I'm going to throw in a graph. So here we go. Okay, so I take this graph and I'm going to say a couple things. So the first thing I'm going to notice is that this is a vertical ellipse with an intercept point or a vertex point at 2 and negative 2. And then I'm going to see that the b term here is 5. So there's my b term, 1, 2, 3, 4, 5. Now if I wasn't confident, which I'm not on my first time doing this, you guys, this is probably not going to be the most, not going to be confident at first, but with some practice you'll get better. I'm going to label those points, and then I'm going to draw in a rectangle that connects these points. Okay, there's the rectangle, and this rectangle is going to be important because this is going to be where you're going to put in the asymptotes. So we'll do a lot of work with the asymptotes, but basically this hyperbola is centered at the origin and goes this way, like this. Okay, there are my asymptotes, and because the hyperbola is shooting up and down, if you remember from our rational functions unit, um, the actual graph of the hyperbola is going to eventually hug the asymptotes and look something like that. Um, let's see. We have a couple more things to do, and I'm sort of out of room, but let me see. So we have to figure out the vertices. So vertice, well, the vertices are easy. They're the vertices. And we need to figure out the equation of the asymptotes. Well, look, here's how I explain it. You're always going to solve for y. So if I take the equation, which I'm about to highlight, if I take this equation and I solve that equation for y, um, you're going to get something like this. Um, see this 4 that I'm circling? Well, here, let's bring it up here for a second. If I solve for y, I'm going to get y squared equals um, x squared over 25 times 4. The 4 is sort of in the numerator. And since we're dealing with values of x that are really, really big, the extra 1, like the plus 1, really when you square root both sides is going to be insignificant. So the asymptotes become plus or minus 2/5 x. I know that's sort of hard to see, and I ran out of room, and this is not good teaching. I need to space it out, so I apologize for that. But the asymptotes here are, this one has a positive slope, so this is y equals 2/5 x, and this line right here, this has a negative slope. This is negative 2/5 x. You could, of course, find the equations of the lines by taking 2 points on the asymptotes and figuring out the slope and plugging into point slope form. The last thing is the foci, which you saw on the notes, is actually a squared plus b squared equals c squared. So real quick, we're just going to plug in a squared plus b squared. So that's going to be root 29. So square root 29 is going to be the asymptotes. So we'll just put, so let's see, square root of 29 is between 5 and 6. So we'll just put a little dot right there, square root of 29, and I'll approximate it here, negative square root of 29. All right, that was a lot for one question. Thankfully, the second question has a ton less work. So let's do that one, and then we'll go to video 2. So write an equation of a hyperbola with foci at negative 4, 0 and 4, 0. Okay, I'm going to recommend on every problem to, even if it doesn't say to make a graph, start by drawing a graph. Okay, even if it's just a rough picture. So the foci is negative 4, comma 0 and 4, comma 0. So we'll label that C. And then the vertice is negative 3. Okay, this thing is sort of off, but there's A, negative A. Okay, so you can automatically see that you're dealing here with a horizontal hyperbola. So here's a rough equation. Remember, it always has to equal 1, and since this is a horizontal hyperbola, I know that because the vertices and the foci are all left to right. So this setup looks good. I know that A is 3, so I know immediately I can say this. Now I need to figure out the b squared. So we come back to a squared plus b squared equals c squared, and let's plug in what we know. Um, so that's going to be 7, root 7. Oh, I guess I could have extended the page here. So here, so now we got root 7. When we square that, we get 7. Here's our equation. Our equation for this hyperbola with foci of negative 4, 0, and 4, 0, and the vertices is given, is x squared divided by 9 minus y squared over 7 equals 1. Keep in mind the foci are not points on the hyperbola, so if you plug in negative 4 comma 0 into this equation, you're not going to get something that is true. But the vertices are points that work, so let's make sure they work real quick. So negative 3 squared over 9 minus, oh that's easy, 0 equals 1. 9 over 9 is 1. We're done. All right, that's the first two questions, and we are going to go on to video 2. Okay? Hopefully everyone's having a good day. See ya.